Okay, in this lesson we're going to be converting a decimal to scientific notation. By decimal we just mean basically a normal number. Alright, so what is scientific notation? A lot of my students ask that. Well, basically the reason we have scientific notation is because the number of zeros that you have for a particular number can be represented by a simple exponent. Let me demonstrate. So let's say you have something like 3.7, and this is a scientific number, times 10 to the 15th. Okay, it's a pretty big number. This is like a space number, like how far away a star might be from the Earth or something. But this is a number that has 15 zeros on it. Okay, so you can see that this number is simpler than having to write out 15 zeros. Okay. The other day we watched a video in class where we saw that basically, now I don't remember the exact coefficient. Okay, let's just say it's like 1.5 or something. Basically, this number represents how long it would take you to shuffle a deck of cards as many ways possible. And you can see that that would have 67 zeros on it. And that's how many seconds it would take. And so it's just a simpler way of writing numbers. It's shorter, and ultimately we can just read that exponent. We'll know how many zeros we have. Now for negative exponents, let's say you have something like 10 to the negative 9. Okay, that would be a decimal followed by that many zeros. Okay, and then a 1 at the end. Alright, so let's see here. So that will give you an idea that this is a long number. Why not just write this? Then we know it's 9 zeros followed by 1. It's a simple way of writing numbers. We use it a lot in science. Okay, the size of a very small particle, for example, Avogadro's number, I think, is 10 to the negative 23, which I believe is the size of a mole or something like that. So, rather than writing 23 zeros, why not just write that? So that's why we have scientific numbers. It's a simpler and shorter way of writing things. So all that being said, let's go ahead and look at example 1. So we want to take this number and turn it into a scientific number. Right now, let's read this together. It's 0.00634. So I'm going to give you the steps to convert these things easily to scientific notation every single time. Let's take a look at the first step. It says to simply locate the decimal point. Alright, now sometimes a number might not have one overtly, so you have to put it there. Okay, but that's going to be easy, and we'll do that in a future example. So in this one though, it's easy, right? Here's the decimal point over here. You might see a 0 over here sometimes. To me it doesn't really matter. I guess I can put one there, just but you don't really need it there, but I'll put it there anyways. Okay, so there's your 0. Next step is going to be to locate the first non-zero digit. Now that's kind of a lot of wording, but basically you're going to read this number from left to right, and you're going to look for the first digit that's not a 0. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are all non-zero digits. We're going to look at the one that's the furthest left for step 2. So we can see that these are 0 digits, right? If we're reading from left to right, okay, we hit 3 zeros, so those don't really matter for the sake of this step. 6 we run into is our first non-zero digit. Okay, if you want to, you can underline that or whatever you want to do. That's your first non-zero digit. Pretty simple. All right, next step. We are going to move our decimal point to this digit. Okay. Now, when we move it to the digit, we want to move it just to the right of this digit, actually. Okay. So move this decimal point to the right of this digit. So my students have done a good job doing this, and basically what we do is we just draw our arrows. So that's what we're going to do. We're going to draw arrows from where our decimal point is. 1, 2, and you can see it takes 3 hops to move our decimal point to the right of that first non-zero digit. So just to reiterate, we've taken our original decimal point, we've went 3 units to the right, and we've placed it to the right of our first non-zero digit. So always place it to the right. That's 3 hops. Okay, and if you want to, you can even kind of show right below your hops that you went 3 units to the right. But you know, I should caution that because your exponent is going to be the opposite of that. So maybe instead of writing plus 3, you write 3 to the right. Okay. So we'll see that the exponent's actually going to be opposite of that, because if you were to convert it back, it would need to be opposite. So determine the exponent. Okay. So since we moved it to the right, believe it or not, when you move an exponent to the right, the exponent's going to be negative. You're going to see why in just a second. Okay. So if you move it to the left, your exponent will be positive. If you moved that decimal to the right, it will be negative. Okay. So that means in this particular case, our exponent is going to be negative 3. Okay. It's the opposite of what you would think. You're going to see why in just a second. Alright, and the final step is to write our number in scientific notation. Okay, this is, to me, basically the easiest step. So we see now where the new decimal place is. These zeros to the left won't matter, they're not significant. So basically all we have left is 6.34. So my final answer, I'm going to write 6.34. And I already show what my exponent was. It was negative 3. So it's going to be times 10 to the negative 3. It'll always be times 10 to the something. Okay. And again, when you move to the right, your exponent is going to be negative. Okay. So that's our final answer. We went from 0.00634 to 6.34 times 10 to the negative 3. We will do a few more. I will show you what it's like when you move the decimal to the left, and I'm also going to do an example where you have to kind of insert that decimal place when it's not visible. If you have any other questions about this example, let me know.